Okay, so this particular battery had a faulty string, which is string 8 or B8. Let's go B1. I got B1 anyway, and goes 2, 3, 4, 5 up to 16. So it's a 60 volt, and it's got 8 cells, and they're 2.5 amps each, amp hours each. So it's big, whatever the heck it is. And it came with this particular BMS, which is a separate port BMS, and the separate port would be, you'd have B minus, C minus, and P for Papa, P minus. Minus means basically it's your black wire every single time. And this one though has only got the C minus and the B minus. No, yeah, that's right, C and B. Now, the customer supplied this because I'm struggling to get hold of this particular model. There's a number of batteries I've seen with this particular BMS. A Nami E, Burn E, has got this on their battery. I've got one here. But its first 5 strings are stuffed. And also the actual BMS is bent, literally bent like a banana. It's only just slight, but it's enough, clearly, for things to go wrong. And this one has got the first pin on that side. The first pin is almost gone. Sorry about this. And that side, the first pin has almost disappeared, and the second one's a little bit scorched. And the wiring for it, like this kind of fella that goes down to the side and onto each of these strings, had shorted and vaporized and mess. And I've been struggling to get hold of this, although I think now I'm about to ordering 2 BMSs of same as this, being 16 string 80 amp, and having the separate port. And what I mean by separate port is that where you connect up your charger to your scooter is the other end of this. Actually, this has another. These are XT 30 amp connectors. On the other end, you've got the other ones, the male pin going to that round socket that you plug into on your charger. So those ones there have got the 2 black wires, which are those there, okay? And they connected up to the charger. And then you've got the P for the power, which is the XT90, huge mothers, which go to the controller, which goes to the motor, okay? The power, high power, high current, whatever. And then the battery side. And the battery, which is minus B, goes to minus B on there. So you got your minus P for your power, minus charge, and minus B for battery. So that's how it's connected up. And of course, they were on the ends. These 2 big thick ones here were much shorter. I had to cut back the heat shrink a bit for a reason, which I'm going to show you right now, is that the customer supplied this BMS. Again, it's a 16S 80 amp. But it's a common port, meaning that the controller negatives, the controller cables that goes to the controller negatives and the power port negatives are joined together on this particular one, which is to here. All right, and then the battery, those 2 there are connected to this one here, or the top 2. They're short together, they're interconnected. That copper and that copper strip are connected together. This one originally would have a screw and bolt, and then you'd have like the ring things that are around that on the end of these. Stupid, but anyway, so what I've done is I've put a bit of solder on there for those 2 wires to solder onto here, and a bit of solder there for those 2 charging port negatives, and these 2 controller negatives go to the bottom here. But because originally these high power ones are at the ends, and I need to bring them round, I had to slit the heat shrink to then get a bit more length to be able to bring it round and solder on those two and those two at the bottom, and then those two on the top, like so. Now the other thing I had to do was to cut out a piece of the heat sink. It looked like this, is mirrored. Okay, so that piece there I cut out on here, and the reason being is because for me to get this flush up and these soldered to it, I actually have to allow the wires to run down here, the cables to run down here at the back for this to be flush, to then solder onto there. Now before I put even this up against that, I'm going to use a bit of this stuff, okay, which goes up there because I want to insulate, protect it in terms of mechanical and electrically, this from the battery. With all the vibrations, I don't want to run the risk of anything rubbing metal on metal or something like that, and then a short and then a fire and all the rest of that goes with it. Okay, so I'm going to cut little slots out, one there and one for this loop here underneath. Let's see if I can get it out of the way. So where that loops around, it will then come up on the inside like that, so I'll need to cut a little slot out there. So the cables are on this side, so that when I solder this on, they're on the right side, okay, of that yellow piece there. This is, I've cut to the right length. All right, it's a little bit over, but that's fine. Now you notice there's also a bit of solder there. That's for the black or the negative wire. Hang on, I've got to find it, of this connector. Okay, the negative wire goes to there. So once I've done that, then she is all ready to go. A bit of work, took a bit of work to do all that. Once I've done that, once I've wired it all up, then I'll do the usual of balancing, fully charging up, using the load tester, 300 watt. All right. That's the maximum it'll handle. A lot of electric scooters, like the Segway 9bots, they're all cheapy ones. They're around about the 250, 300, 350 watt. So it's almost like a small motor load, it works out to be. And this being, I don't even know what the capacity is of this, probably 18 amp hours as a wild guess. Let's see, what is it? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2.5. So 16 plus 4 is 20. So 20 amp hours this one is. And the voltage is, I think, maximum voltage is, the voltage is 60. So that'll give you 600 plus, say, 1200 watts. All right. So it'll take 4 hours for that to discharge this battery here. All right. That's a long time. And once I've discharged it fully, then I'll check and check the voltages between each string, and it's got to be less than 50 millivolts or 0.05. 0.05? Yeah, 0.05 volts. 0.5 is 500. So 0.05 is 50 millivolts or better. And if it is, great, and then I'll balance it still, and then I will charge that with the normal charger, okay? And then I will check the balance again, and again they should be within 50 millivolts. The last battery I did was 12 millivolts, if you recall, if you watch my videos, which is fantastic. I wasn't expecting that, but it was 12 millivolts, which is brilliant. I hope the same for this one, even after replacing with the cells that are 2.6 amp hours, as these are 2.5. If you're going to replace cells, always put cells in that are slightly higher capacity. They don't need to be full. They don't need to fully charge up, but these ones do. And because they're only 2.5 amp hours, this one in theory will charge up to 2.5 amp hours, so it meets its minimum. If you put something like a 2 amp hour 2000 milliamp hours, all right, into 2.5, that'll be charged up before those by 500 milliamps. And being a dum-dum BMS, it'll only look for the first group or string that reaches 4.2 volts, which will be obviously this one if it was 2000 milliamp hours, and then it'll shut down, and that means all the others are not fully charged up. Now, I did with this one, I did put them through the ringer, put them through there. I had to go through a number of them to find ones that were in perfect condition, because these aren't brand new, they're second hand. I got some spares here which are in perfect condition. They're meeting their capacity and their resistance level, which is necessary, so they're within range. So there was a couple there out of the 100 that I had, thereabouts. And so I've nickel stripped, I've welded them in place, top and bottom, so that's already done. And now I've just got to solder this up and tape it all up, etc. Now because this is going to be longer, because this is thicker, if you notice, we'll just check this, see the thickness difference between the two. Hang on a second. The lighting in here is not all that fantastic. All right, see, there's a difference in width, and that's enough to cause a problem in not using the original casing. So I've ordered more of the sheets, and I'll cut it to length. The width and the height and the width are no change, just the length. It's going to be about 10 mils, because the other issue is the new one is slightly higher. It's at 65 and this is at 60. So the original was sitting low. This one is sitting up high, and it'll be up against the soldering and etc. So to avoid any issues, mechanical or electrical, I have to put that in place, as I said, and then that goes on front. So therefore, peoples, that battery's got to be longer. And once I've put that in place, it's all taped up and insulated with this stuff, and more than likely I'll get more of this barley paper and use that as well. Just probably go overboard, but I don't care, as long as I feel safe in doing what I'm doing. And once I've done that, then I will size up what I need in terms of length and cut it, and then box it all up, and then heat shrink it all up again. But that's not until I've done all the basics in charging, discharging, confirming the capacity of the battery, confirming that it balances well, then I will box it all up. All in good fun. I don't need to have this in place when I do the balancing, because when I do the balancing, these balance wires will be connected up to each group, and then the balancer itself, the black box, that fella there, connected up to there. I don't need this fella here. This fella, well, actually, I've contacted the manufacturer, but they haven't responded as yet. I'd like to be able to test it on the BMS tester. Now, these two here, I have got the specs and the information. I've got the company that supplied me that BMS tester to talk to this mob, Best Way, and they do sell. They've sold BMSs to various scooter manufacturers that I've seen around here. That's how I found them. And I've got this is I think that's a 13S and that's a 14S. So I've got all the information necessary when I hook up my laptop to this, connect it up to whatever port, the USB connection. All right, goes to the back and controls this fella, and I can use the laptop to put in the data I need to test those two to make sure they are working perfectly well. So I want to do the same for this. But they haven't responded as yet. So yeah, just got to wait. And the ones that do replace this that I'm about to order, I've spoken to the two manufacturers. That's with the separate port ones, not this, but the ones got separate port, same spec but separate port, like this one, which is what I want. I've got the pro forma invoice to pay for 2 of each. When I get it, I've also got the specifications to test it, and then I'll hook it up to that fella there to make sure that they're working fine, and that one of those will most likely be fitted to the Nami Burney battery. That's that one there, that big mother. That's got the same BMS as that other one behind me that was connected. That's for a, not a Zero, but for a Vsett 10X. This one's for the Nami, and it has dead cells B1 to B5. B1 to B5. And that's a huge big battery. It has a huge big battery. And yet that one there is only 18650s. They're not 21700s, which surprises me. I haven't got any news yet, but more than likely I'm talking to the people who supplied me the brand spanking new Samsung 21700s. Will supply me the necessary cells to fix up that Nami. I think they're 20, 1, 2, 3, 4, 5, 6, no, I don't know. They've got lots of inside, 10, I think, in each string. So it'll be about 50 cells, I think it is, to replace. And I'll just order in 100, because there's other batteries around. I like those ones there. And some of them down here need some cells. So yeah, bit of work. If there's any questions, don't hesitate to ask. Bye for now.